Welcome back to the second video in my series of the 2017 Advent of Code challenges. Today I, for whatever reason, decided I would do the second Advent of Code day in Haskell. Prior to this video I hadn't done anything more complicated than multiplying all the numbers in an array in Haskell. The actual challenge I was solving was the second day of the Advent of Code from 2017, in which we are given a set of lists of numbers. For each line of the input we need to find the minimum and maximum value for each line and find the sum of the differences. This seemed like it should play into Haskell's strengths, being a contrived algorithmic array-based problem with no real-world value. I started off with a Hello World program, which, being not really my code, was simple and worked well. Next I tried taking user input and printing that. Understandably, GHC refused to talk to me until I kept my variable names consistent. Next I get blocked by VS Code having its output window not allow me to type any input into it. Fine, I'll just take up half my screen with the terminal and use that to build and run my code. Next I start looking into split functions and install a library using the package manager. This, when combined with my lack of understanding of Haskell array syntax, doesn't end up working very well. So then I spend way too long messing with possible ways to get anything working again. At some point I stumble upon the lines function, which appears to do exactly what I want, splitting my input at all the line breaks. There is also a corresponding words function that breaks the input at spaces. These seem to work nicely, and with some extra help from the map and read function I get a 2D array of integers. I can even get an array for minimums and an array for maximums for each line of my input. Unfortunately, I don't know how to perform operations on corresponding elements from parallel arrays, so I have to create a function that returns the difference between the min and max of an array that is passed to it. This seems to be working surprisingly nicely, so I sum the array of differences and it just works. Now begins the suffering. Each line of our input has exactly one pair of numbers that divide to give a perfect integer. We need to find which numbers these are and take the sum of all the division results. I rather quickly figured I would use one number modulo another, equaling 0 to indicate that they divide perfectly. I start creating a findDiv function similar to my maxMinMin function I used for the previous part of the challenge. To start with, I try doing a multi-line function creating two parallel arrays. Then I remember what I said earlier about not knowing how to get parallel arrays to be useful to me. To try to get some more ideas, I start working on an addIf function, which takes two integers and a boolean, and returns the sum if the boolean is true and just the first number if the boolean is false. I also explore some ideas around a doLine function to process each number against the rest of its line. I then spend a while trying to figure out how to convert it into an array containing zeros where it doesn't divide and the division result where it does, and then return the sum of the elements. In doing this, I modify the addIf function to only take one integer and a boolean and return either the integer or 0 based on the boolean. To help do this, I modify the addIf function I made earlier to take only one integer and a boolean and return either the value of the integer or 0 depending on the passed integer. Now all I need to do is figure out how to pass both a boolean value, whether the modulo is 0, and the actual division result using a map function. At first I try using a subfunction thing I found online to help do these calculations. However, I don't put much time into figuring out how to make this work before deciding it's probably going to be easier just to use a normal function. So I create a do1 function that takes two integers and returns x over n if it is a whole number and 0 otherwise. I then tweak my doLine function to use this new do1 function. Then I make findDiv call doLine for every element of each line of input. I also need to take the sum of all of the values for the entire line, so I add another function wrapping my findDiv function in an attempt to stop findDiv becoming too complex. The final thing I need to do is take one away for each element on each line because all the numbers are divisible by themselves, which keeps adding ones to the value that the challenge doesn't ask for. This proves to be surprisingly difficult to figure out how to do, but eventually I get there with yet more functions and I get it working. Now we can sum up the values for each line and submit the totals, showing that our solution is correct.